In this lesson, we're going to talk about parallel circuits. Let's use these two examples. So as you can see, we have a power source. The electrons are going to come out the negative side, travel down this path here, go across whatever the load is, and come back on this side here. So let's look at this a little closer. I put the values in here. Let me move this up to 10 volts. Same with this one. So if I look at this circuit right here, I can see with the light bulbs in it that the electrons are coming out of the negative side. I have 10 ohms, 20 ohms, and 30 ohms. As you can see from the beams of light, that more electrons are passing through the lower resistance. Now we know that to be fact. The less resistance, the easier it is for the electrons to flow. So because there's more electrons flowing, the light is going to be brighter. So you can see here, the electrons are flowing through here. Some are coming off. Looks like every other one. Coming down here. Every other one. And then the rest of them are passing through here. So if we get our little spot on amp meter, we can go across here. And if I look right here, this is going to be my total amps, because this is before any of the loads. So I have 1.83. If I go right here, I only have 0.83, and if I go right here, that's 0.33. So if I put it in, actually on each load, I got 1 amp going through here, half an amp going through here, and 0.33 amps going through here. If I get my voltmeter and stick it right here, I know that I have on this point right here, I have my 10 volts. Now I can leave that negative side there because it's all hooked together, and I can touch right here, and I got 10 volts, and I can touch right here. And that would be the same exact as if I put the leads on either side. So if you look down here to our resistors, you can see the same thing. The electrons are coming through. You just can't see the little beams, but you can see that they are moving at the same exact rate. 1 amp's gone through here, half an amp's gone through here, and 1/3 of an amp's gone through here. So in a parallel circuit, the voltage is the same across every load, as we could see, 10. The amps change through each load depending on the value of the load. So if these were all 10, the amps would be exactly the same. 1, 1. And this one's still going to be the 0.33. So, using Ohm's law, which is right here, we know that to find anything, we need at least 2 other things. So right here we can see if we want to find voltage, we're going to need either one of amps or resistance. If we're going to find resistance, remember you put your finger over it, we're going to have to get volts and divide it by amps. And if we want to find amps, remember you put your finger over it and we're going to have volts and divide it by resistance. So let's look at this circuit right here. And what we're going to do is we're going to say this is 10 volts. We're basically going to make the same circuit we just made on the other side in the other diagram. So this is going to be 10 ohms. This is going to be 20 ohms. And this will be 30 ohms. So R1 is 10, R2 is 20, R3 is 30. So I have all of my resistance here and my volts. Now, in a parallel circuit, it's a lot different than a series circuit. In a series circuit, we would just add the values up, but in a parallel circuit, we can't do that. We have to 1 over x them. So to do that, we're going to get 10 ohms 1 over x plus 20 ohms 1 over x plus 30 ohms 1 over x equals 1 over x. Now let's get our calculator out. So to do that, we're just going to hit this 1 over x button right up here. So we get 10, 1 over x, plus 20, 1 over x, plus 30, 1 over x, equals, and then don't forget, it's so important, we hit that 1 over x button one more time. And our resistance total is now going to be, so we have 10 volts total. We have our resistance total. And I'm just going to round this up. And now I can find my amps total. Now my amps total is going to be, remember when I did it on that other diagram? That's going to be the total amps that are going to go through the battery. Not for each branch, but the total amps. So the total amps would be measured right there, and then the amps through each branch would be right there. So I could figure this out a couple ways. So for total resistance, I 1 over x, 1 over x, 1 over x. And then I have my amps. Now I could go back and double check things, but we just want to worry about resistance right now. So we have our total resistance. And with Ohm's law here, we can find out our total amps. Now, let's look for amps. So this was 10 ohms. This one was 20 ohms. And this one was 30 ohms. And we had 10 volts. Now when we 1 over x'd everything, our volt total equals 10. Our resistance total equaled 5.4. And then again, remember I rounded it up. I rounded that 4 up. Omega. Now if I want my amp total, all I need to do is get this number and divide it by that number, right? Ohm's law. I have volts and I have resistance. I can find amps. So let's get 10 divided by 5.4 0.8455 equals, and we're going to call that 1.833. 1.833 amps. Now I can also find amps a different way. I can find amps for each branch. So if we remember, our volts total, which is on every single load in here, is going to equal 10 volts DC. Now I can find the amps for R1, amps for R2, and amps for R3. And that's really easy. So what do I need to find amps? I have resistance and I have volts. So each one of these loads gets 10 volts. This one is 10 ohms. So I would get, for R1, it would be 10 volts divided by 10 ohms, and 10 divided by 10 is 1, so I can say this is 1 amp. R2 would be 10, well, you can make that line go across there too. 10 divided by 20, 10 volts, 10 ohms. So 10 divided by 20 is 0.5 amps. And for R3, that would be 10 divided by 30, which I know, but we'll just do it in the calculator anyway to show you how to do it. 10 divided by 30 equals, and there we go. And if we add them all together, because this branch and this branch and this branch, if this point right here is my total amps, and then I just measured right here and got 1, and I measured right here the amps and I got 0.5, and I measured right here. So again, let me write this down. So 1.833 amps, and then this one's going to be 1 amp, 0.5 amps, 0.333 amps. So if you remember, the electrons are going to come past here, and there's going to be 1.833 amps coming past this point, and then they're going to split, and then they're going to come all back together again. So this point right here will have 1.833 amps, all meeting back up to head on the other side of the battery. All right, so we figured out resistance and we figured out ohms. We figured out resistance in ohms and we figured out amps. Let's talk about volts. So using the numbers from before, we had 10 ohms here, 20 ohms here, 30 ohms there. And then I knew that I had 1 amp here. And if I had, let's just say I had 0.5 amps here, but I didn't know this one. But I did know the total amps. 1.833 3. Could I find voltage? I could find voltage a couple ways. I could 1 over x all these. And have my resistance total and multiply it by my amps, and that would give me my volts. I could figure out this missing one, which I don't really need to, but I could because I have these two, so I could add these together, and 1.5 or 1.833 minus 1.5 is going to equal 0.333 amps. So all I did was get these two and subtracted it from this one. But the easiest way to do it is I know that each one of these branches has the same voltage. So I could 1 over x, 1 over x, 1 over x, and then multiply it by that. Or I could just get these two, which are these two, and multiply them together. So I could say the voltage across R1 equals 1 times 10. And that's going to equal 10. And I could say the voltage across R2 equals 20 times 0.5, and that equals, wow, 10. Now remember, always put volts DC or whatever in there. Or I could say the voltage across R3 equals 30 times 0.333 equals, and it's going to be 9 point something something something, but we can just round that to 10. All right, so there we go. Now we have all the different ways to find voltage, amps, and resistance in a parallel circuit. If you have any questions, don't forget, you can always ask Mr. Haynes.